So, hi everybody and welcome back. This is a C++ tutorial series for absolute beginners. This is video 140, and in this video we continue with exercises, but this time I will read here a question and then you should pause the video, try to answer the question, and then you will see how I solve this, which means I will of course not pause here. I will just read the question and continue answering the question. Here you can see two lines above these questions, and these two lines above these questions are links from here, which is cppreferencecom. I will use this website for resources, for syntax, for examples. So all the questions which I use here are from this site. And the first line means if you type in, for example, in the browser cppreferencecom and then useful resources, you will go exactly to the page where you can find special answers or examples. And of course you can type in as well this link here, then you find it as it's the same, just the link version. So with that said, one more thing, which is I will not provide a full answer here. What I mean with that, these are more theoretical questions, and I will just give you one example of all the variations, and the rest you have to read in this website and read through, try to understand it, or read on other websites or on C++ books what you have. And yeah, with that said, let's get started. All right, first of all, why I'm using in this tutorial cppreferencecom? What do you think? Why I'm using that? The answer is preparing for official C++ documentation. And so this is the answer, because let's go here fast to cppreferencecom. Like I said, this site cppreferencecom is a copy of the official papers. And what are the official papers, by the way? If you go to useful resources in cppreferencecom, then there are some many things here. And here, when you see these numbers here, the strange numbers here, these are the official C++ documentation and the working draft. For example, there are different versions, and you should try to go for the latest version. And then there is a PDF format, an HTML format. And let's click on one of them and see what the official papers are. And you see, for example, in PDF format, the official papers is working draft standard C++, and this here C++, what I'm using here, this cppreferencecom, is more or less a simplified and compact version of this one here. It's similar to this one, but more simplified. So when I go here anywhere, let's why it's not doing that, not reacting. Oh, it's reacting now. All right, when I go anywhere here, for example, you can see this one is the formal definition, formal declarations, and for all formals for C++ documentation. And our goal is also to learn to understand this. And that's why I'm using cppreferencecom, because this is a little bit more easier than the official ones. And but still, we need still a little bit time. That's why I said you should not start with this one as well. You should go first with official books for starters, and yes, for beginners, where all the terms and names are introduced for beginner friendly and so on. This one is not beginner friendly, and this other official papers as well not. The reason for that is they make all-time examples with all the possibilities, which means, for example, if I go here, for example, let's dive into the keywords. For example, we know for loops, right? But when we see the examples, what they use, they take in account that you already know also structs, for example, that you know already all other possibilities which we have not discussed yet. And that's why I said you should start with a C++ book and not with this one. But now we have the problem that, not the problem, let's say now we are aiming step by step more and more to understand all these words, this syntax, this identifiers and all this kind of stuff we have to learn. And our goal is to use this official papers here, which is our ultimate goal, because in future, if you try to understand something, then you can go directly to the official documentation and watch how it is defined, and you will understand it. So that was a long explanation here, but this one here is very important. That's why it was very long. The other ones I will make very short and say just read, but this was very important. That's why I make here a little bit more talk. So let's go into now a little bit faster, right? And like all time, pause the video after I read the first question and then try it yourself. All right, let's go to where can I find the best answers to the frequently asked questions? Where you probably know StackOverFlow. This one is a very famous website. There are of course many other resources as well, but this site is very famous. If you write this in your browser, for example, let's go here, let's write here StackOverFlow and then ask a question, for example, what is a function pointer, and click this, and you can see there are similar questions like you. And here is on the top, there is one who is asking, but you have to read what is he is asking and say, perhaps you have to find another way or describe your question a little bit different. And then you will see here are many people who are answering. Some are answering it formal, some are answering more beginner friendly. You have to try and understand it, how they answer. And yeah, this is the one way to find very, very good answers online. And yeah, let's continue. 3. Why many programmers and cppreferencecom and official papers use short identifiers. Identifiers means variable names, class names, function names, and all the names, right? Identifier is just similar like name. So why they use all time short variable names? Here, why they use this? For example, here we have here a, we have here something like t, and then we have a function f. So answer is, simple answer is, they are not programming. They are not programming. What they are doing is they are explaining or demonstrating concepts or whatever. Right? So what I mean with that is, you can see, for example, here, it says here the expression this shall not appear in any other context, and then they are demonstrating just a code snippet. They don't care about the variable itself. That's why they call it a, for example. They don't care, for example, the identifier here for the function name, what it should mean, because they are trying just to explain you the concept of, for example, in this concept, this one here. And that's why they use here short variable names, and the answer is just they are not programming. We are interested in programming. We will use long variable names. So if you are trying to explain a concept, you can use as well short variable names or for demonstration purposes and so on. One more thing about short variable names or identifiers. The problem with this short identifiers is all these things what you try to explain becomes abstract. Abstract means hard to understand sometimes, because all these identifiers become not very important, and many beginners and many people have more problems if they can't understand this one in context, which means they try to make examples because they think that's very important to understand. Then they try to decipher this. So careful about this one as well. Abstract is not very good. in general, it's not good. It's used in math, and it's used, like you can see here, in demonstration purposes. It takes time to get used to, but if you are already used to this kind of abstract definitions and abstract presentation, then it's not a problem, but many people don't like it. So just a reminder. Let's continue. So why we use in this tutorial all time very long variable names? I hope you know this. Because readability, what else? Readability and rule equal one time reading, because this one, and understanding context. So what I mean with that, I hope it's clear, because like I said, when you read here something, what is A here? You don't know. What is using int sz? I don't know, not readable. And then you have to decipher this, which means you have anyhow to analyze this and try to understand this context. We don't know. So that's why we use in this tutorial all time very long identifiers, which means we want to understand with one-time reading what the intention of the variable is, where it goes, why we use it. So all these W questions, right? And one information here, additional information, don't use unnecessary information. For example, don't make something like this. This is a long name, so use this. A variable name like this makes no sense. Or identifier name, a long identifier should not contain unnecessary words, which gives not information about the context or intention or something like that. Here in this example here, this is a long name, so use this. Okay, we have here information this is not informative. Long name, perhaps informative, so use this, makes no sense. Here the only useful part was long name. Perhaps you need a long name for anything. It's still not specified, but it's better than all these unnecessary words here. So which means, careful, when I talk our long identifier, I mean all time that gives you more information about all this background information like context, why we use it, where we use it, and so on. Let's continue. Here, 5. What is the pro tip I gave you in this tutorial when I talked about identifiers? That was a very short talk. I said, let's write here, pro tip is identifiers let you analyze, or let's say identifiers let you spare time. Let's make it so. Identifiers spare time, which means, what means that identifier spare time? This is very, in general, what I wanted to point out is if you know very good names, or and you remember them, and you know and perhaps you remember the libraries, and all this kind of stuff will help you to go faster and faster in the future. Let me make you here an example. We created here down this main, and then we created here this login account, and here this identifier, this is a function identifier, for example, this login account here. This name is very good, because if you know what a login account is, and we created this, we learned how our login account works. We don't need really to watch this code here, because we know what to expect in this code. Without analyzing the code, when I see something like that, I know exactly that I need an input for username, probably for password. Then I have to compare this in the database, and then that's it, for example. And when I peek then here the definition, and you see, I don't need to read all and analyze all things. I see it instantly. Yes, asking for username, asking for password, check, and here it's checking and then accepting. Okay, this is very simple, but think about it. You have something like a very big library, and if you already know it, then with a good identifier name, this is not wasting time more. You don't waste time to analyze it. Let's compare it with something like that. Look, this code is very simple, very easy, right? But because we used here very bad names, I have to analyze this one, what it is doing, right? So I hope you get the idea. And this is in future much worth, especially if you want Go Pro, which means they use anyway libraries, and they are more they need more good identifier names, so they know what they are using. So let's go on. Also, what are the benefits for you or your employer if you use short identifiers like this one? This is a very strange question. I talk about benefits with short variable names in project and not demonstration. In project means really coding. If you see a question like that, you can forget it most times, just as a hint, but let's write some benefits. What is a benefit? Less time, because they are short, you don't type so much, and faster progress, because if you have less time, let's write faster progress, and that should be it, and not too much. I don't waste here too much time as well, because in general you will see this is not good. So the next question is, what are the consequences for you and your employer if you use short variable names like this here on top? This is the same things, but the consequences. So let's say you made a project here, you used short variable names. Yes, you get less time to create this project. That's because you use less variable names. You are happy because less time means cool. Faster progress, because less time to create the project made faster progress, which means you have more free time or more money. Let's write here also free time, more money, depends, because if you have more free time means you can spend again more time and make more money. That sounds really cool, right? But now the consequences. What are the consequences? Let's say every project needs probably bug fixes. Bug fixes will cost much time first. Then every project need, probably not every, but most project need updates. Every updates will take more time. And now these are, let's say these are the consequences, but what are the next consequences with this one? Here we said you have more free time, you have more money, and here we have to say, let's make here perhaps this one, oops, not this one, Control Z, this one, and here we have the opposite negative effects here. You thought you have less time, you will spend much time, faster progress, update will take more time, so which means not so fast progress. Free time, no, you have more money, you will have less time, which means less free time and less money. And there is one more consequence which is very important if you are working, for example, a company. So if you are not making a project for yourself, you will be probably not hired. They will not take you. And the reason is for that is because if they are experienced and they know, for example, bug fixes and updates will come for sure, and they see you are using very unreadable names, again, something like that, when they see you are using a coding and use short variable names, which is hard to update, which means when we add here code and we need this code, then we have to analyze this code again and waste time for analyzing, or when there is a bug, then we read this code here. We have first analyze this code to understand the bug, and that is all time waste, which will lead also to money, less money for the employer, and he will kick you out. That sounds harsh, but this is the reality, because most employers, they think only about money, of course, and that can cost also, of course, here one more important, can break full project. Depends on situation. Let me give you an example. For example, there are game projects. They release the game project, and after the release in the first day, there is a bug, and because they could not fix the bug fast enough, they could lose millions of, let's say, thousands of players, which is a loss of money, right? Something like that, and trust and so on. But this is future topic. Let's skip this. I hope you get the idea what I want to say here. That's very important for the future, but not right now, but we still should know it. Okay, now a little bit more practical examples. Let's go. So first, here, write a variable declaration. Here it's important that you know what a declaration is. Okay, I write a variable declaration. I write, for example, int my telephone number. That is a declaration. Careful, this declaration here, what I wrote here, is also a definition. This is a special case because with variables. And if I write a function declaration, for example, int my function declaration, this one is a real declaration. This one is a declaration and a definition. And the reason for that is this function needs a body for a definition. This one has already all information behind the scene, and you should read this a little bit more in detail if you don't know what I mean here. So I keep this both here as an answer and go on. 9, of course, you can read here in declaration and use this link here. In declaration cppreferencecom. All right, I should write this also here, cppreferencecom. Perhaps all right, so you get the idea. All time when you read here on top, I mean also cppreferencecom, or all time in the other places. All right, let's continue. Write a variable declaration with initializer this time. Okay, let's take this one here because it's similar. Here, I paste this in. Here we have what we have here, identifier. We have here type, but we have no initializer, and we should write an initializer. So I have here to this identifier here, which is also called a declarator, by the way. Here we have a specifier, and I should write an initializer, and you probably know this one. We write this almost all time. Here I use this assignment operator, and with this form we have a copy assignment, which means we have a copy initializer. All right, let's continue. And of course, if you don't sure, you can go here in initializer here again in cppreferencecom all time, and here in initializer, go on top here, perhaps here. Yeah, this what I want to show you here is declaration with initializer. Yes, this one. Yeah, okay, I want to show you that this one is our copy initialization, this one here. All right, let's continue. 10, explain this line here. What is this line? Try to explain it. I write now the answer. Answer would be, for example, syntax is a syntax, but not the official it's a syntax. That's enough. It's a syntax. And careful, this syntax, what we are going to learn will be something like that. And when you go here to the syntax places, if I find any, there are any, of course I have to go here, for example, on top, and then let's write here Control F for, let's go declaration, here's some declaration, why is this not there? I don't know. Declaration and definitions. Let's go here. And you can see here, is there some syntax though? No, they don't have here. Anyhow, they have some declarations and so. Okay, we skipped this, but what I want pointed out is we will learn in future this kind of, these are examples, these are not declarations actually, the syntax I mean. We will learn, of course, this syntax here from these official papers, but important is here there are different kind of syntax formats, which means you will see different kinds. Important is here that you know these names here later. Type, identifier, initializer is a syntax, and let's make an example. We already have here an example here on top. This is exactly perfect. Int is our type, identifier is our name here, and initializer is our equal, and then here with a value. And these angel brackets are skipped, and all other parts we need. For example, we need this one, we need the curly braces, and all only these angel brackets are here for demonstration or format purposes, so can be skipped, and all other parts you need or need to define. All right, I hope you understand this one and read this. There are different kind of syntax, and we will learn more syntax in the future. So next one. In declaration, we have the question 11. What means declaration specifier sequence? The answer is, I think it's a, yes, it says it's a declaration. It's a sequence of declaration specifier. Let's see the official answer. Declaration, we go fast in declaration on top. Here, declaration introduce. Okay, that's not the place. Says here in declaration, should be, it declares, okay. Yeah, the official answer for declaration, but I wanted to go for declaration specifier. Specifiers here, declaration specifier. No, this is a declaration specifier. There's not. That's not the answer. Declaration specifier sequence. Yeah, it's just a sequence of a specifier. Just keep this in mind. So it's a sequence of specifier. That's right here, just sequence. It's anywhere here. I don't know where, but it's something like that. Sequence of specifiers. That's it. It's right, I think, but I don't know where it is. I want to show you the official thing here. Important is here you should know this here, declaration specifier sequence is very important. For example, here, when we have a simple declaration, for example, they use this kind of term a lot, declaration specifier sequence. And what is a specifier sequence? We have here specifiers, and then you can try to find the specifiers here, what you know. You don't know all because there are many things which we have not talked about yet, many other keywords, but some of them you know. For example, this section you should know, this simple type specifier, char, int, and so on. And this is here in our example as well. Here, this is a specifier, this is a declarator, and this is our initializer, and something like that. So if you have a list, first of all, you need to know specifier. And here you don't know all, just try and watch what you know as training a little bit. For example, this one sounds a little bit strange, but this one is const volatile, const you know. And yeah, check this out. We go on with our questions. 11, what means declarator? Oh, that was just that. 12, what means declarator? This is again exactly here. We have our variables, like I said, this one here explains exactly our declaration here. And like I said, this name here, I call it identifier, but they call it also identifier sometimes, but in terms of syntax, it's the declarator. And this is just one example. We can see this here. We go here. We learned the specifiers. This is display is here in front. And here is our list. Now we learn the declarator, and declarators, like I said, is the name of a variable or a function or a class, which we learn in the future, and so on, just the name or something other, because here is a list what all declarators can be. Here's a list, and what you know, try to read a little bit here through and find what you know. You should know this one, the name, for example, and when I click on this one, here it says name, a name is used one of the following to refer of an entity, an identifier, exactly that we know. And you see it's a little bit jumping from one place to one place. Sometimes it's okay. We have not talked about entity, but we will talk about this one. It's also a very important word to distinguish about other things, but that's later. All right, let's go on. So here, what was the question? What means declarator? Let's write here just, it's a short answer, is yes, identifier. Most time example, for example, let's write here, for example, identifier, identifier. But of course you can see this is only one possibility about many, and that's why I can't make them right, because declarators are here and you see a list of possibilities, and the only one which I specified here as an identifier, for example, which we know because in our example here, my telephone number, here we know this is the variable name and this is an identifier and this is our declarator. Good, good, good. And here are other versions. All right, but we have not to know, of course, all, just concentrate on them which you know, because it's very important that you start to get used to these names. And go on to the next, here, 13. What means initializer? And that's very easy. We have already initializer here, right? This one. This is an initializer, okay. Let's try here to find the official answer. I could write here a random answer, but let's see what the official answer is. Here, initializer. Initialization of a variable provides its initial value of the time of construction. The problem is here they are saying of a variable, but that must be not necessarily a variable. But let's copy this here one. And important is initializer. Is this only variable? You can initialize other things too. Most time it's a variable, yes. Okay, this is the official answer, and of course initializer in our case is just something like that to initialize this one. But let's see what you have to know. Yes, we will talk about initializer in a moment more here. We skip all the other part here on the bottom, but here we will talk a little bit more. Let's go on. Okay, where we are here. We solved this one, and here 14. What means reading inside out? Do you know alternatives? Okay, this one I have not really called it inside out, but I showed you how we can read complex, for example here, declarations or something, or functions or whatever. And I showed you this website here, I think. And this is a way how you can read complex things. And what he is here doing is similar to this term inside out. And this inside out you can find in declarations, I think, a little bit down here. It's one of these ways to read. There is another way, for example, spiral rule, but this one is not working all time. That's why I think we should not use that. Instead, we should use this inside out rule. And when I go to inside out rule, it is exactly this rule here. It shows you how to read this. And here, these examples here are explained here. I will not read this through. You can see it. This is the answer. Here again in StackOverFlow, they posted it here. Here's the answer for this one. And here is the answer for the second one, which is a little bit more complicated. I copy, let me copy the last line at least. So copy this one here. So you can read this last line. All right, it was a little bit too much. Let's see what we have here. What is that? White. Let's go right here, white. Let's do here. Okay, let's do this one. All right, this one is the answer for that one. And yes, and try this one out. Important here is that you know this term inside out or this alternative, which was this site here. How to read this, I said he explains how to read very complex things, and that was his example. And this is really complex when you see it first time, but when you read the rule, it becomes very easy because you can follow a rule. The problem here is we have not discussed all the things which comes here. He is using some function pointers, I think, again, or double, I don't know, is he using double pointers, something like that. Anyway, you can read this. All right, we continue. We have to do a little bit more. Yes, and should I copy this one here too? So we have an answer at least, right? I should copy this one too fast. No, I think you can really read this one. I showed you this. You can pause the video and watch it again. So let's go on. Number 15. Here it says, what is declaration specifier sequence and declarator in this examples? All right, we have talked now about this declaration specifier sequence here on top. We know the declaration specifier sequence is, for example, where is our example here? Where is it? Okay, here, let's go here, just here. Here we see the declaration specifier for this one here. Let's make it the easy one. It's just int. And here, and the declarator would be this one. But careful. The problem is there can be nested declarators. And yeah, and I will not do this one here, answer, because this takes a little bit time and much writing. That's why I show you the answer, which is in declaration in cppreferencecom. Let's go there to declarations. Go to examples in, and here down in examples, I skipped the first one. We have not talked about classes right now, but here, this one is the answer for the first one, and you can read it here that you have to read, and you see the declarator specify sequence is just the int, and then we have here a little bit more. For example, it says then a one is the declarator. A defines an initializer variable of type int, which is this one here, and then p and so on. This one we have not discussed, pointer to functions. We will discuss in the future a little bit, but it's you can just take it. And here we have also a pointer to function, which we have also not discussed. And here, use also the read rule. Don't forget this one. Here's this inside out rule. When you try to read something like this, it's complicated, but not that. If you learned this one, it becomes easier and easier. The more problem is that we have not discussed all this structure. Like I said, this function to pointer. With that said, you should read this one here and try to understand this one. And then you are training exactly these two things. You should really train this and train this one, because we need these two words, and this one is good examples for that to train. And you see that I can't write all here out. That will take too much time. That's why I say here cppreferencecom. Right here in declarations, you go there, and that's it. Let's continue. Here 16, write your variable initializer in two other syntax and explain what's the different what the different is what the different is. And okay, explain what the different is, which means we have right here on top our variable. I copy this one fast and I put it here down. I paste it in. This is our first version, and now we have to write this in two other syntax formats, which means in other initializer. All right, let's do this. Can you do this? You should do this. I need to copy this part here because I need this all time. And I write this now in other formats. One would be 5422. And the next format would be this one. And when we go here, 5422. So what is the difference? And then we should explain what the difference is. This one, which we used all time, is a copy is a copy initialization, which is normally bad because let's write here comment bad because narrow conversion possible. And here this is similar. This is similar. Let's write here one more comment, but all time used. But all time used. And this one is similar to this one here. The problem here is we can't talk this in depth now because we have to learn constructors, and constructors comes with classes. And when we learn constructors, you will see the real difference about them, because the constructor defines here a lot of things, and then it makes sense why this is different than this, because normally they are just initialized all the same. And here in this case, and this is the version which we should normally use, normally we should use this because no narrow conversion. All right, this is the version which we normally should use. Here a word to narrow conversion means this one here will make a conversion, which means it converts this value here behind the scene to a int if it's not a int. For example, if I make here accidentally, or let's say I have a value and write 5422 behind the scene, this one will compile and give you no error, but it will cut this off. And this is not our intended behavior of C++, because C++ should be type safe, and this one is against the rule more or less, because we use here a double. This would be a double, and here we assign it to an int. That's violating the rule, and that's why they invented later this one here, because this list initialization, which means if you try to write here 0.64, the compiler will give you an error. Then the question is, okay, if this is so, why all are using then this? Because I said here bad because narrow conversion possible, but all time use. The reason why all are using this one is it's not confusing, because this version here and this version here can confuse in many programming parts, because these curly brackets are used in so many blocks, for example, or in other use cases, and the same goes for this round brackets, for example, distinguish between here when we have something very long here, you are using this for separating parts or make them executing before. For example, you should use foo in this place here before you would use, for example, foo in this direction. And because we use here this parenthesis, we have to read here foo pointer and then go to this direction if you know this direction rule in this case. So important thing is here, let's say this was the reason why we should normally use this one here. All right, and let's see, let me show you something more. There is one more thing. Yes, not here, initializer was that. Here, yes, here are the 3 possible initializations, right? Here, this is that. This is that what we all time use. This is the official syntax here. Initialization syntax. At least this is a little bit simple. Here, here, and here. Good. Let's continue. And here, initialization. Write code examples for. Okay, here we have now write code examples. Let's write them here. Value initialization. First of all, what is a value initialization? You should explain this perhaps. Write code examples for and explain. Let's write here and explain. All right, here you should explain as well. So value initialization is you are writing a declaration and what you are doing. Value initialization is what is going on? Directly copying the list initialization. Yes, the problem is I should describe this right. Here, this one is a value. Yes, I should describe this right. Okay. Value initialization means just that you initialize all values to 0, but important here is you are not using this literal 0, and this is a little bit confusing. What I mean with that is, let's make an example. I watched anyway the answers. Yes, perhaps I skip this and no, let's make this, or it's get a little bit confusing here. I copy this one here. Yeah, let's make this one here and write this one here, perhaps this one here. But value initialization means I initialize it to 0, but it's only possible with list initialization and not with direct initialization, because that would be make it to 0. And if you say now, wait a minute, we can set it here to 0, that's not value initialization. If you set, for example, this to 0, this is just initializing to 0. It's not the same as value initialization, because this one here will set this value to 0 for you if you use this here. All right, I hope you should read this, right? That's why I said it's a little bit strange. You can click on this one here and then read this a little bit. That's perhaps a little bit difficult because we have not talked about this one. Or you can ask online and see what they are saying. So, but like I said, the problem here is with this initialization is we need a little bit more information about classes, because this initialization is all time coupled to construction of a object, and construction of an object means all time creating this object, and these objects are anyway classes more or less behind the scene, which means they have all time something like called a constructor. In future we will talk more and you will understand all this kind of stuff here more in depth, but right now it's okay if you understand it. So let's go direct initialization. Here is a direct initialization. I copy just this one here and put it here, and here we have this direct initialization. That is that, and explain it. Yes, it is used here with this round brackets. And again, let's try not explain this one. I need again the copy constructor to explain it in depth, would take too much time. We go on copy initialization. Yes, this is this one here. This is my first one. Let's copy this one here. All right, this is my copy initialization, my list initialization. This one is actually the first one here, and you say, wait a minute, is this not value initialization? And you are right. But of course I should write here value, then makes it sense. Now I have here, for example, a value 5422. Of course I could write here more values, depends on the type. Here I can't write more values because we have here an int type. But when you go here to list initialization and click here, and let's see some examples here. If they are some example, no, this is again with structs which we have not talked. Like I said, sometimes I use examples which we have not learned yet, but you have to find examples perhaps which we know. And yeah, you can watch these examples and see here. Here you can see here the first one here, value initialization. Like I said, they use this empty one. Direct list initialization. Okay, here it's called direct list initialization. It is called here normally list, but here they call it direct list initialization. You have to read then here the change what they mean. And yeah, and here they call initializer list. Yes, okay, because we have here more values. Probably that's why they call this. Or there are other reasons. Anyway, you can read it here. List initialization of a PR value. Again, interesting. Here again, this one. All right, you will get it, read it, and we go on. Aggregate initialization. We have not talked about this name here, but aggregate initialization means just an array initialization, and arrays we have initialized, which means how we initialize, we create an array. Let's make an array int my database array. Let's call this one, and for example, let's make it here this one. Let's make here 2, for example. Of course, we could make here also 2-dimensional, but I don't make now 2-dimensional array because I want to show you the initialization of aggregate installation, which means just simple. This one here is our aggregate initialization for arrays. It's very simple, and here is the answer. This one looks here with chars. They have made it with chars. I made it with numbers, int numbers. And reference initialization, we have made this also, but of course it looks here a little bit strange when you see this example here. In our case, what we did so far was most time we defined first normal declaration of a variable. So let's use our telephone number here, or any of the other ones. They are all more or less the same, and then we can reference to it. So what we do is then here, for example, int reference, careful, this ampersand has many different meanings in different positions. Here it means a ampersand, but we learned also that this one can mean a address of operator if it's placed on the right side in front of a variable name. But here it's a reference, and then we give this a new name. For example, my here this one will my target, so I call this reference to, let's call it reference to my telephone number. And how we reference it, we just assign it, right? And then here this one, copy this one, assign it. And this one we also talked here when we click on it a little bit more. The syntax here, you can read a little bit the real syntax here. Sounds a little bit, it looks complicated, but it's actually very simple. Just try to understand here the syntax a little bit. This T, like I said, they use all time this shortcuts here. You have to get used to T. Ref T means most time type, and the ref is the reference, which means here in our case the name, the reference name or the identifier, and then so on. And here you can read anywhere the explanations, not all time, but most time. And yeah, I think you will figure this out. And here the example, by the way, let's see here if we have here other examples. Yeah, not really. On the bottom here. Here is an example, like I said, our standard example. They make here exactly what I did more or less, and then first declare a variable and initialize it here, and then you just reference to this all time what we did. And you can try to all time watch these examples through and see what you know, what you don't know. The things what you don't know is possibly what we have not talked. For example, this one here, we have not talked about volatile. But this one here you should know, I think. Yes, const int crn. You should know this, I think. And careful when you see something like that. Think about initializer. You can see they use here copy initialization, direct initialization, list initialization. They swap here really with all the different kind of initializer. Train this a little bit. We as a programmer have to learn this. And you can watch these examples here again, okay? Then we go on and we finish with this one. And I think this is the last question, one more, which says here, what is the default initialization? All right, explain this code example. First of all, what is the default initialization? And the default initialization is just an initialization. This one here is a default initialization. So I don't need to write next. Okay, we write an answer here. This one is a default initialization. Let's write here is a default initialization. All right, this is a default. Let's write it this way, so we know this is a code. This one is a default initialization, and then I should explain this. What happens here with a default initialization? Default initialization means that the variable here will be treated. Again, we need this constructor normally, but let's make it simplified. It means that this variable is treated without value. Very simple, there is no value, and that's why this value to this value is behind the scene. The compiler gives a value to this variable. That's why it's called default, because the value is indeterminate, right? At this point, we have a value. Most time when I compile this one, let's do this one. I show you this very fast in main, what I mean with that. When I talk so much, it's hard to grasp. So when I make this one, I point here in, I start the program, it stops here, and let's see why it's not stopping here. Here, it says here, nothing. Okay. Let's make a std out x. I'll start one more time. Now, what's the problem? Yes, that's exactly the problem here. That's a problem here. Exactly that. Okay. We keep this one. We go up. And where is that? Here. Yeah. So the problem is here. When you make this one here, it gives a default value behind the scene. And this default value is called indeterminate, which means it's not terminate. And when you try it and something like that, use this variable, which is not initialized by you, then it will have an undefined behavior, and that can cause problems, right? And sometimes you will see that this value is still initialized, even if it's a default value, and there is an exception for this. Oh, wait a second. Close this one. Let's go to the default initialization, for example, here. Yeah, there are some exceptions. All right, you have to read here a little bit through. There are some exceptions. For example, we have here this exactly this example what I showed you there. Here they made here a little bit more examples, and something here more examples. You have to read this through. All right, and read this and try to figure out why this one is undefined, and sometimes it's not undefined. And the reason for that is it's anywhere here that it says there are some exceptions. For example, here respond except in the following cases. Yeah, all these cases are exceptions. There it will work, but here in this case it will not work. And this is exactly the case where it's not work. And the reason why I made this one is you should initialize your values when you create it, right? You can see what happens. It can happen that it becomes an undefined behavior because you thought I need just declare a variable, it will take a value anyway behind the scene. No, it's not working this, and that's why I made this example. So all time initialize your value, then we have no problems here. And with that said, I stop here the first part of our repetition, and you see it was much theory, and you have even more work to train a little bit this side here. I hope you know many things about this, because most of the parts you should know. The only really new thing is that we are now using this site a little bit more intense and learn these words. And if you already read a very good C++ book or something like that, you are familiar anyway with these words. Important is here, we need to get familiar with this C++ syntax here, or terms here, and all this kind of stuff here. And the reason for that is the first question, why I'm using in this tutorial cppreferencecom, because we are preparing for the official C++ documentation. Our ultimate goal is to understand this one here. If you are able to understand this one here in the future, then you don't need to ask anyone anymore. You have just to test the code with this background knowledge, and if this is not working, then you still can ask around, but normally this will work if you understand it correctly. All right, with that said, If you have any questions or any complaints or any suggestion, tips and tricks, write it in the comments. And this was part 1. We will continue. We still have much to repeat, but you see, it's not just repetition, it's also a little bit extension, much work for you. And I hope you was good. And yeah, with that said, good luck. See you in the next, and bye.